Kia ora Year 13. This is the last part of the 2017 Probability Concepts paper, and it's the one that's all about a game involving spinning 3 spinners. It's definitely the hardest part of the paper, I think, and you have to be very careful to understand the structure of this game. So the score for the game is the median of the 3 numbers that the spinners land on, and they've shown us an example of one game, and they've said that the score is 1. So let's look at it. We've got 4 things can happen on each spinner. They're equally likely. And so here the score turned out to be, well, the spins turned out to be 1, 4, and 1. So putting those in order, we get 1, 1, 4, and the median is 1. So the middle number each time is going to be the score. And when the game was played 50 times, this dot plot shows what happened. So calculate an estimate for the probability of gaining a score of 1. So the probability of getting a 1 is, out of 50 times, how many times did we get a 1? Count up the dots and it's 7. So that's it. Super easy. 0.14 or 14%. Please, please, please do not write this down. 7 out of 50. Okay? No. Right? We want a fraction, a percent, or a decimal. That's a little achieved question. Now the next bit is to calculate the theoretical probability of gaining a score of 1, assuming each spinner is equally likely to land on each of the 4 numbers. So there are several ways to do this. I'm going to do the slow way where we start to think about all of the outcomes. But at this stage, all we've got to do is to figure out the theoretical probability of gaining a score of 1. But if we go further through the paper, what we have to do is to complete the theoretical probability distribution for S, which is the score for the game. So in the next question, we're going to have to work out all of these anyway, 1, 2, 3, and 4. But there's one thing that we can notice that's going to make it a little bit easier. And that is that the probability of the median being 1 will be the same as the probability of the median being 4. In other words, our distribution is symmetric. Okay? I think most people in Year 13 are probably going to miss that fact. So I think the slow way of doing it is actually the easiest. So what we're going to do is just think about how many possible things there are that can happen. And we've got 4 outcomes on each dice. So if you want to think about it as a huge tree, you can. You've got 1, 2, 3, 4, and then you've got the same thing again. So you're going to have 64 outcomes. What we've got to do is work out how many of them are going to have 1 as the middle number. So let's think about how that can happen. We'll do the 1 part first. So 1, 1, 1 is going to get me a score of 1. 1, 1, 2, 1, 1, 3, and 1, 1, 4 are all going to get me a score of 1. As soon as I have not 2 1s, the median won't be 1. Right? So if I have a 1 and then a 2 and a 3, or a 1, a 3 and a 2, I'm never going to be able to get a median of 1. So what I'm looking for to find this probability is all of the ways of getting at least 2 1s. So the first one is kind of the exception. If we get 3 1s, we get a median of 1. So now how many ways are there to have 2 1s and 1 of something else? So we get 1, 1, 1. And then if my first number's 1, I could have 1 and 2, or I could have 2 and 1. 1 and 3, or 3 and 1. But I could have it that the first number is the number that's not 1. So I could have 2 and 1 and 1, 3 and 1 and 1, 4 and 1 and 1. And the bit that I forgot over here, which was a bit stupid for a maths teacher who's meant to work systematically, but there you go, is 1, 1 and 4. So I'm going to go through that again quite slowly. Just skip it if you've got it already. We're looking for the probability, theoretically, of having 1 as the median, right? So we've got 3 spins filling up the 3 boxes. We've got to have 2 of them having 1s in them and 1 having whatever else, we don't care. So what I'm trying to do is list all the ways to get 2 1s. The first way to get 2 1s is to get 2 1s and then a third one. Or we could get our 2 1s first, and then we could get 2, or 3 or 4. The next way is that we could get the 2 1s happening in positions 1 and 3. And the middle number could be 2, 3 or 4. And the last way is if the other number happens first. So 2, 3 or 4, and my 1s are happening here. So altogether that gives me 10 ways to get a median of 1, right? So 3 ways to get something that's not 1, and 3 positions for that to happen in, plus the weird case of getting 3 1s. So the theoretical probability back up here is going to be 10 over 64. Right, now that's a huge mess. So we have to support our answer with appropriate statistical statements or diagrams. So if I were marking, I really wouldn't want to see what I've just done. What I'd rather see, I'd be quite happy to see that to start with, but then I'd like to see something more like this with a heading that says this. So outcomes that give 1 as the median. Okay, so some kind of communication that that's what we're doing, and then listing those 10 outcomes, and then out of total outcomes equals 10 out of 64. Okay, now that's the probability of getting 1. What I'm hoping you're starting to see is that the probability of getting 4 is going to work in exactly the same way. Because 4's at the other end, I need to have 2 of the numbers to get a median of 4 are going to have to be 4. So then I'm going to have the same types of 10 ways to get something else. I can either get a 4 and 2 4s here and another 4, or I can get my 2 4s here and I can get a 1, 2 or a 3. Oh, I quite like this box way of doing this question. Right, so or I could get my 2 4s here and a 1, 2 and a 3. So that's 3 more outcomes. And lastly, I could get my 4s as first and third, and then a 1, 2 or a 3. So all of those are going to generate a median of 4. So the probability of 4 is also going to be 10 out of 64. Right, so that's quite nice, because when I come to the next question, we have to fill up this table. And so we've got this one done. This is 10 out of 64, or 5 out of 32. And this one is also going to be 5 out of 32. Now, here are my 2 and 3. I could say this. By symmetry, the probability of the median being 2 is going to be the same as the probability of the median being 3. And by symmetry, we're going to have half the distribution here and half the distribution here. So also by symmetry, the probability of 1 or 2 is going to equal half of the possible outcomes, so 32 out of 64. So the probability of 2 is going to equal 32 out of 64, take away 10 out of 64, which will be 22 out of 64, or 11 out of 32. Okay, so that's how we get those. But the alternative, okay guys, so I don't know if you heard that, but I'm being yelled at nicely by my family to go and have dinner. So I'm just going to show you the long clunky way to do this, which I reckon most of you probably would have done in the exam, and that is just to get your piece of paper and write all of the outcomes down. So we've got here 1, 2, 3 and 4, and you're going to write out 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4. You've only got 64 sets of numbers. It's really not that bad, so you know, just get over it and do it. So 3, 1, 1, 3, 1, 2, 3, 1, 3, 3, 1, 4. Then look at the median. 1, 1, 1, 1, 1, 2, 2, 2, and so on. And then just count them up. And you're going to get the table that we got before, which is 10 out of 64, 22 out of 64, 22 out of 64, and 10 out of 64. It's at about the limit of what I'd be happy to do by hand, but I reckon if I were in year 13, that's probably how I would have done it. If you're confident and if you're doing, for example, if you're doing lots of problem solving, scholarship calculus, other maths, then you're probably going to enjoy doing it this way instead. So it's over to you. Okay, that's all for today. If I get some views, I'll make some more. If I don't, I'll probably not. So let me know if they're helping, and good luck with the revision.